the first part of the question in 2019, I intentionally left out the last part because it had to do with a trigonometric function. So in this part of the video, we are going to talk more on the integration of trigonometric functions. So we have to integrate cos cube x sin cube x dx. Okay. Now, before we go into that, I would like us to do the basics of the integration of sine and cos. Now, I would just like you to have this diagram in your head. Okay. Have this like this. Now, I have sine x here. I have cos x, negative sine x, and here I have negative cos x. So when I go towards this direction, I am differentiating. It's differentiation. And when I go towards this direction, it is integration. Okay? So to the right is differentiation. So when I go clockwise, it's differentiation. Anti-clockwise, it is integration. So if I differentiate sine x, I'm going to have cos x. If I differentiate cos, I'm going to have negative sign. But I would like to just remove this x to know that when you differentiate the sign, you are going to have the cos. If you differentiate cos, you have negative sign. And if I differentiate negative, I of course have negative cos. Now if I integrate sign, I have negative cos. Okay? So if I integrate cos, I'm going to have sign. So going anti-clockwise is integration, clockwise differentiation. Okay? Now what if I have a function that has to do with, if I have cos f of x, for example, and I have to differentiate it, differentiation of cos f of x with respect to x, okay, is the same as, what we simply do is we differentiate this function here. So mean I'm going to take f prime of x. Now I differentiate the function itself, which is going to give me negative cos. So that's why I'm going to have that differentiation of cos f of x. Remember, when I differentiate cos, I have negative sign. So I'm going to have negative f prime of x sine f of x. Okay? So the differentiation is in two parts. You first of all differentiate the function, then you multiply by the differential of the trigonometric function itself. Now here, if I differentiate sine f of x with respect to x, I'm going to obtain, so I differentiate my function, I'm going to have f prime of x. Remember, when I differentiate sine, I have cos, so I'm going to have cos f of x. That is for differentiation. Okay? Now, when I integrate, how is it going to look like? If I'm integrating sine f of x with respect to x, it's going to give me, remember when you integrate sine, you have negative cos instead. Okay? But now in this case, what do we do when you differentiate f of a function? You rather divide. So I'm going to have f prime, 1 on f prime of x, okay, times negative cos f of x. Okay, so when you differentiate the function, you multiply by the integral of the trigonometric function. Now if I integrate cos of f of x with respect to x, what do? I differentiate my function, so I'm going to have 1 on f of x. Okay, then when I differentiate or when I integrate cos, I'm going to have sine. So sine f of x. Okay, so that is the integration. This is the differentiation, and this is the integration of trigonometric functions. So let's move to the question itself. So the question says you should integrate cos cube x sine cube x dx. Now this is going to be equal to, I'm going to teach you a trick in this case. Now in this part here, we should understand what we call trigonometric functions. These functions can be written as cos cube x, okay, sine cube x dx. Okay. Now, according to trigonometric identities, sine squared x plus cos squared x is equal to 1. Okay. Sine cos squared x minus sine squared x is the same as cos 2x. Okay? But the identity I would like us to use here is the first identity. This one is the double angle identity. Now here we are going to talk about the sine squared x plus cos squared x equal to 1. So it means that I can be able to make one of these the subject of the formula. So if I make sine squared x subject of the formula, I'm going to have 1 minus cos squared x. Now I can write this one as integral of cos cube x, okay, integral of cos cube x sine squared x times sine x dx, which will be equal to cos cube x. In the place of sine squared x, I can replace it with 1 minus cos squared x. So 1 minus cos squared x times sine x dx. Okay. Now remember, so just recall this. Recall that sine x, okay, is the same as sine x is the same as differentiating. When I differentiate cos x, normally I have negative sine x. Okay, if I differentiate cos x with respect to x, I'm going to have negative sine x. But here I have positive sine x, so I can simply just add a negative here. So it means that normally this is it. Okay, so if I want to have positive sine x, I simply divide both sides by negative, which implies that negative d cos x dx is simply equal to sine x. Okay, so here integral from of cos cube x, so I can expand the bracket, so I'm going to have cos cube x minus cos to the 5x. Now in the place of sine x, I can replace it with negative d sine or negative d cos x dx times dx. Okay, this other dx that is going to be here. So this dx takes care of dx, right? And I'm going to be left with integral of cos cube x minus cos to the 5x d cos x, and then of course I can bring out this negative sign this way. Alright? Now, what does this imply? This will be equal to, you see, I can differentiate now with respect to cos x. So it means that if my cos x was equal to u, this one will be like u to the power 3 minus u to the power 5, and of course with respect to u, I'm differentiating with respect to cos x, not more with respect to x. So here I'm going to have the integral will simply be minus, so if I integrate this one, I'm going to have cos to the, with respect to cos, I'm going to have cos to the power 5x or 4x, cos to the power 4x on 4 minus cos to the power 6x on 6 plus 3. Okay. So that is the integral of the function. Drop your comments in the comment section below, and if you have any problems, you can always state it there. Then maybe if you need further explanations, we can try to see how to do that. Alright, thank you very much for watching, and keep on checking your notification bar for more videos. Thank you very much. Thank you for watching the video, and if this is your first time on the channel, please don't forget to subscribe to the channel. You like, you comment and you share the video. And don't forget that our preparatory classes for the different concourse after you finish your GCE starts on the 12th of July this year, that is 2022. It's going to start on the 12th of July at our different centers. We have 5 centers. We have 2 centers in the southwest, one in Boya and Andanke University Institute besides former police Monico. We have one at GS Likumba, that's Government School Likumba in Tiko. We have 2 centers in Bonaberi, that is one at FIMAT, that is one located